Physics. Let us learn some problem handling techniques which is suitable for any competitive exams. Problem number 1. The time period of a pendulum constructed by hanging a metal bob of mass 300 gram with a string of length 36 cm is where elongation due to tension is neglected. Options given are A 2.4 seconds, B 3.8 seconds, C 10.8 seconds, D 1.2 seconds. What we actually teach in school is time period is independent of mass. Let the mass be 300, 600, 1 kg, 1 ton. It does not depend upon the mass. So the student doesn't have to worry about the mass. Formula here used is T, which is equal to 2 pi root of L by G. The students start substituting the value of pi as 3.14 and the given length is converted into meter as 0.36 meter and approximate value of G is taken as 10 meter per second square. He multiplies the value and he got 6.28 into 0.036 and the units after cancellation it becomes second. Now the student looks at the value 36, that is 36, and in his mind he gets the closest square root, which is 6. Now he multiplies them both and he gets the value 3.768, which is very close to 3.8 seconds, which is in option B, but his answer is wrong. The student has to be very careful while taking roots of decimal places. Now, the square root of 0.036 is actually 0.189 and not 0.6 as he has preassumed. So here is a chance of the student getting wrong. And when he multiplies 6.28 into 0.19, he gets a value which is 1.1932, which is very close to 1.2 seconds, which is in option D, and here is his answer. This sum cannot be done by a student within a minute, but it is expected by the student to be finished within that time frame and accurately. We are not helping the student in getting close to that. How can we help the students to get close to that is going to the next step in shortening these formulas, in getting to do what only has to be done. According to the applications, the formulas can be reduced and they can be taught in the schools. Actually, this is the duty of every teacher. It is not only to teach only what is given in textbooks, and it is the duty to simplify things. That is the evolution in education. Here, he will be able to save more time and be more precise. For example, this time period on Earth can also be found using the formula 2 into length, so root of length with no units divided by 10 into seconds. How does this work? All he has to do is 2 times take the root of 36, which is given in centimeter, only the magnitude we are taking here, 36, and divide by 10. So it is 2 into 6 by 10. So 2 into 0.6, it is 1.2. So he has got the answer already. So he doesn't have any chance of getting it wrong. And this answer is the same as he got after so many calculations. This seems to be simple and easy, but many teachers would ask, why is there a change in formula? Is this true for all similar sums, or is this just a trick? So now we shall reason out why this formula time period t equals to 2 pi root of L by G has transformed and used. Now we get this from the formula 2 into the value of pi is substituted as 3.14 into root of length in meter by acceleration due to gravity. So here, instead of acceleration due to gravity, we have changed the value as 9.8 meter per second square. In this step, the magnitude of length is taken separated and root of 9.8 is separate, and the units have been taken as a separate part of root. So meter and meter get cancelled. Second square when taken as root will transform into second. So we will get the next step such as this. Now if you take the root of 0.98, the value is 3.13, which is very close to 3.14. So you can directly cancel it out, and the formula becomes 2 times the length with no unit into seconds. Similarly, when we check the correctness of this answer, it is 3.13 divided by 3.14 into 100, which gives the percentage of accuracy, and it is 99.68% accurate. And this way of finding answer is very easy and quick. And if the measurements are given in centimeter, we follow these steps, where we have in the denominator place 100, where for the transformation of centimeter to meter, and when taken the root it becomes 10. So the same steps, only thing is here we have in the denominator 10 as additional. So the student in mind, he has to just double the root of the length given and put a decimal point in between, so he will get the answer. So these are the formulas. Whether it is given in meter or centimeter, you can find the time period on earth. By teaching this, we can go to a step ahead for the student. Even for finding the time period on moon, he can use this formula. Just by 5 times multiplying the length with no units in seconds, he gets the value of time period on moon. And length with no units, when after finding root, if he just divides it by 2, he gets the value if it is given in centimeters. So pretty simple and pretty easy. All you have to do is, when it is given in meters, he has to just multiply. On earth he has to multiply by 2, on moon he has to multiply by 5. And when it is given in centimeters, on moon he has to divide it by 2, and on earth he has to divide by 5. So here when I say 5, the student may get cancelled. So it is 2 and 10 can be cancelled, and it can be 5. In this slide, we will see a new relation which have been arrived from the above sum. Pi square is very close to the value of gravity on earth. Is that so? Let's check it out. In NET, if we check for the range of gravity on Earth, it is the lowest in Peru Mountain, 9.7639, and the highest at the Arctic Ocean area, it is 9.8337. So only between these values the gravity lies. So we can check our values. So when we take the square root of 9 point, the lower values, that is 9.7639, we get 3.124. And when we take the square root of 9.8337, we get 3.135, which is very close. And when we multiply find the square of 3.14, we get 9.856, which is very close to the higher end value. But in schools, we use this value also, square root of 10, because 10 approximate value of gravity for some applications, some are used. When this is allowed in schools, why can't this also be allowed in schools? Because 3.16 is very far from 3.14, and the value of 3.16 square, if you take it is 9.98, and it is out of the borders of the range of gravity on Earth. So we can also teach them pi squared is very close to gravity value. So they get a relation between pi and gravity, because and as Earth is a sphere, pi should be there and gravity should be related with that. Let us see some similar problems where the question is given with values length in meters, and we have to find time period on Earth. The formula we are going to use is 2 times root of length with no units into seconds. Let's see how quick we can do that. So in this question we are not bothering about any mass. So 36, root of 36 is 6, 6 2s are 12, 12 is the answer. Next question, 64, root of 64 is 8, 8 doubled is 16. And in this question, 16, root 16 is 4 and doubled 8. In this, root 49 is 7, so double it, it is 14. In this question, it is 121, so root 121 is 11, and when it is doubled, it is 22. So here we are very clear, the student doesn't have to look at the masses and doesn't have to worry about any other steps. Similar problems here, when we have the length in centimeters and to find the time period on Earth, it can be done like this. So the formula I used is 2 times length with no units and divide by 10. So whenever we divide by 10, we just put one decimal point. From the right side we move one place and put a decimal point. Now let's check the answers. So the questions, the masses are different. 36, root 36 is 6, 6 double is 12, so 1.2 seconds is the answer. Here 64, root 64 is 8, double 16, so 1.6. Here we have it as 16 centimeters, so root 16 is 8, root 16 is 4, and when it is doubled it is 0.8. And for 49 it is root is 7, so 7 doubled is 1.4, so we have this 1.4. And 121, for 121 the root is 11, and when it is doubled it becomes 22, and we put a decimal point from the right side, one place moving, so it is 2.2 seconds. So the answer is 2.2. Now when we have the problems such as this, with the question having length in meters, to find it on moon, obviously we don't have these questions, but even in on moon the student will be able to answer, because he has just to do 5 times into length of the roots, that's all. So for the first question, 36 root is 6, 6 5 are 30 is the answer. And for 64, 8 na, so 8 will be 40, 40 will be the answer. And for 16, root of 16 is 4, so 4 5 are 20 is the answer. And for 49, root 49 is 7, 7 5 are 35 is the answer. And for 121, root 121 is 11, so 11 5 are 55 is the answer. Pretty simple. Now similarly, when we have the length given in centimeters to find the time period on moon, we use this formula. Length with no units, find the root and divide by 2. Here 36 is given, first question. So here 36, root 36 is 6, so 6 by 2 is 3, 3 is the answer. 64, 8, 8 by 2 is 4, 4 is the answer. 16, root 16 is 4, so 4 by 2 is 2, that's the answer. And 49, 7 will come, 7 by 2 is 3.5. And for 121 it is going to be 11, and 11 by 2 is 5.5 seconds. Here we have to observe that the student has no idea of the question, no idea of what the mass is, nothing. The student's eyes get accustomed to it. So it may be a plastic mob, whatever material, it does not independent. It does not depend on any kind of material. It depends only on the gravitation and the length. So this is how we get this formulas done, and this is really pretty simple when it is given to the students. Now let's have a look at the first problem what we did. So we had this question and this is how the student worked. Now we have this solution and it is properly reasoned out. Now this seems to be simple and easy, isn't it? We just solved 20 sums in just 2 minutes of both Earth and Moon. Isn't this enough for a proof how the students will feel and learn easier? And it is easy to remember too. To find time period of simple pendulum on Earth or on Moon, he has to just remember the question may be in meters or centimeters. They don't have to worry about the mass of the bob. Time period is independent of the mass. All he has to do is first find root of the length with no units. Just multiply by and just divide by. When it is for Earth and Moon, when it is in meters, he can clearly remember it is m meters, m multiply. So all he has to do is, when it is given in meters, he has to multiply by 2, and for the Moon he has to multiply by 5, and it is the reverse. When it is given in centimeters, for Earth he has to divide it by 5, and for Moon he has to divide by 2. So the numbers are not different, 2 and 5. Similarly, more than 10,000 sums can